So our pH scale runs from 0 all the way to 14, and 7 is the middle. So let's do a little bit of labeling here. So if you have a pH of 7, most people will readily recognize that this represents a neutral solution. As you move from 7 towards 14, okay, we see a decrease in the hydrogen ion concentration, an increase in the hydroxide ion concentration, so our solution becomes more basic. And an old-fashioned word for something that's increasing in its hydroxide would be alkaline. So it's alkaline. Whereas if you go from a pH of 7 back towards a pH of 0, in this direction we see an increase in the hydrogen ion concentration. There is a proportional decrease in the hydroxide ion concentration. So as you approach a pH of 0, the solution becomes more acidic. Now, whether you know this or not, but P means negative log and the H is the hydrogen ion concentration. So pH means negative log of our H plus concentration. So let's take a look here of what this means, what the P value means. So hydrogen ion concentration, I'm going to short form it a little bit. So it would be 1 times 10 to some sort of exponent, right? So the concentrations are typically in scientific notation. So it's 1 times 10, and it is the negative P value. And then this is just taking it out of scientific notation and putting it in decimal form. So I'm just going to put in a couple of these. They're not going to be spaced out, but we have a pH of 0, we have a pH of 1, a pH of 3, a pH of 5. Okay? So what this means is that if our pH value is 0, that means it's 1 times 10, and I'm just going to put the exponent 10 to the 0. If our pH value is 1, it means that it is 1 times 10 to the minus 1. If our pH value is 3, then it's 1 times 10 to the negative 3. If our pH value is 5, it's 1 times 10 to the negative 5. So the power of 10, its exponent, is the negative P value. So there's a direct correlation that I want you to see here between the pH value and the exponent of the concentration. Okay? But what I also want you to think about is if we take this out of scientific notation. So we have 1 times 10 to the 0 power. That means the decimal does not move. So if we took this out of scientific notation, then we would just see it as like 1 molarity. If it's 1 times 10 to the minus 1, that means we need to, if we take it out of sign notation, we need to move the decimal 1 place to the left, so it would be 0.1 molarity. Now we have 1 times 10 to the minus 3. So that means to take it out of side, we've got to move it 3 times. The negative means move it to the left because it's going to be smaller than 1. So it would be 0.001 molarity. And then the last example, if it's 1 times 10 to the minus 5, we've got to move the decimal 5 times, but we move it to the left because it's negative. So the concentration would be 0.00001. So you can see what happens. So as you move from a pH of 0 towards a pH of 14, take a look at the concentrations. Look at the decimal forms where we see that so our idea is as we see an increase in the pH value, we see a decrease in the concentration of the hydrogen ion. So the closer you get to 14, the less hydrogen ions there are swimming in the solution. It becomes less acidic. So we see a decrease in the acidic nature of the solution, right? It becomes less acidic. So let's take a look at some problems here, okay? So we have a solution that starts off with a pH value of 4. So if we have a pH of 4, right, then I want you to be able to write the concentration. So here we understand that the H plus concentration is 1 times 10 to the minus 4, right? Now, in this question, more acid is added. So the pH increases by 100-fold. So take a look. If we're here at minus 4, more acid is increased, okay? What is the new pH value? If this should read that that shouldn't say pH, the H plus concentration increases by 100-fold. So, and let me just go back here. I'm going to write this in decimal form. So decimal would be 0.0001. If the pH is going to increase, do we want to see this become a bigger number or a smaller number? Well, if the hydrogen ion concentration increases, we want this to become a bigger number. So take your original concentration, right, and multiply it by the factor that it's going to increase by, 100. So now my new concentration, that would be the same thing as taking this value, writing it in decimal, if you have trouble seeing it, and multiplying it. This is the same math. So it eliminates. So this would equal 0.01 or 1 times 10 to the minus 2. So now if I know my new concentration, the exponent tells me the p-value. So my new pH value equals 2. And a pH value, a pH value of 2 has a higher concentration, is more acidic than a pH of 4. Just look at these numbers. Okay? Taking a look at a similar problem. So in this problem, we start off with a pH value of 5. So if I know that my pH value equals 5, then I understand that my hydrogen ion concentration would be 1 times 10 to the minus 5, or I can write it out in decimal form, which would be 0.12341. That would be the decimal form of this, right? And notice that my pH value is becoming less acidic, right? What pH is less acidic? So if it's less acidic, that means that we need to see a decrease in the hydrogen ion concentration. Well, what kind of math will make this number become even a smaller number? I have to divide it. So I'm going to divide it by 1,000, or I can divide the decimal form by 1,000, right? So whether it's the decimal or the exponents, my new concentration will be 1 times 10 to the minus 8. So I already have 1, 2, 3, 4. I have to put in 3 more zeros, right? So 0.1, 2, 3, 4, 5, 6, 7. So there we go. Here's my new concentration. And if I know my new concentration, that exponent value right there will tell me the pH. So therefore, the pH that is 1,000 times less acidic than a pH of 5 would be a pH of 8.